So good morning for our 5th module, Quality Control. So quality assurance and quality control. So dalawang term na ginagamit natin to provide the best system or accurate yung ating mga results. So start natin sa quality assurance. So quality assurance is a complete system. So isang buo yan system of creating and following procedures and policies to aim for providing the most reliable patient laboratory results and to minimize errors in the pre-analytical, analytical, and post-analytical phases. Pag quality assurance yung ating tinutukoy, ito yung kabuuan ng ating quality management, yung pag-provide nga ng magandang mga results. So quality assurance monitors quality performance starting from the ordering of laboratory determinations to its reporting. So mula mag-request ang pasyente or ang doktor hanggang sa ma-release or ma-report natin ang ating mga results. The interpretation of results and the application of the patient care. So usually hanggang doon tayo sa reporting. Interpretation of results, mga doktor na naggagawa. Application to the patient care. So sa mga doktor na din yan. So quality assurance involves total quality control, which requires constant attention of all involved in the process or the system. So the principle is that every laboratory section must have a plan to address pre-analytical, analytical, and post-analytical testing. So ano ba yung mga yan? So pag pre-analytical, ito yung patient preparation, sample collection, transport, and storage. Analytical na, ito yung nagpa-perform na tayo ng testing sa ating mga samples. So, the condition of the reagents and the equipments, pipetting, quality control, personnel competency. So, sa quality assurance, kabilang or pasok din dito, sakop nito yung quality control. So, mas mababa yung quality control compared sa quality assurance. Last is post-analytical. Ito na yung reporting of results, timely releasing of results, and record keepings. So, timely releasing of results, usually 2 hours yung ating mga turnaround time. Pero may mga tinatawag tayong stat or kailangan agad may result na. Record keeping, meron tayong nakastate sa ating mga laws, sa mga batas, kung gaano katagal natin kinikip ang ating mga records like requests, yung mga results, tsaka yung pa mga kailangan, quality control. So, depende yun per section. So, quality assurance, procedure manuals, so ito mga SOP natin, formatted according to CLSI standards, must be available for procedures and must be followed by personnel explicitly. So, ito yung atin dapat susundan. Dito tayo magbe-base ng ating mga gagawin or mga decisions sa ating laboratory. Instrument maintenance and calibration procedures and documentation of the same must be in place. So, yung ating maintenance and calibration dapat documented yan para kung magka-problema, punta lang tayo sa ating documents, makikita natin sino, ano ang ginawa, bakit nagkaroon pa rin ng problema. Problem logbooks should be used to identify potential problems and course of actions implemented. So, kagaya din nun, if may encounter na problems, usually nire-report natin as incident report, nire-record for the future references. Kumbaga, ano yung ginawa dati, ano yung gagawin natin ngayon. Indicator should be identified to monitor potential problems, threshold sets, and data collected. A quality control program using control materials that resembles patient samples must be run exactly as the patients. So, iba nga yung quality control sa ating quality assurance. So, terminologies associated with quality control and quality assurance. So, sensitivity, so the ability of the analytical method to measure the smallest concentration of the analyte. So, high sensitivity, ibig sabihin none or low number of false negatives. So, matitingnan lahat ng meron ng sensitivity or yung meron ng analyte na yan. Specificity, the ability of the analytical method to measure only the analyte of interest. So, kumbaga, yun lang yung target natin. So, halimbawa, ilagay natin sa coronavirus. So, maraming coronavirus. mataas ang specificity, ibig sabihin mapipinpoint natin yung specific coronavirus na kailangan natin. For example, yung COVID-19. So, pag mataas specificity, mataas yung chance na ma-detect yung COVID-19 lang against the ibang coronaviruses. So, high specificity equals low number of false positives. So, matetest mo lang yung positive lang talaga. Wala kang masyadong false positive. Accuracy, the extent to which the mean measurement is close to the true value. Kumbaga, malapit ka talaga doon sa value na kailangan mo. Indicates how close to the true value the results is and is counter-checked using the mean. So, estimated using 3 types of studies. So, yung ating accuracy, pwede mong estimate gamit ito. Recovery, so determines how much of the analyte can be identified in the sample. Interferences determines if specific compounds affect laboratory results like hemolysis, turbidity, and lipemia, or kung may iba pa siyang interferences. Patient sample comparison, used to assess presence of error in actual patient sample. So, precision naman, indicates how close the values are to one another. So, kung gaano kalapit sa isa't isa yung ating results. Counter-check using coefficient of variation. Terms related to precision. So, repeatability. Closeness of agreement between results of a successive instrument carried out under the same conditions. So, kumbaga pinaulit-ulit kung pare-parehas ba rin ba yung results pag pinaulit-ulit. Reproducibility. Closeness of agreements between results of measurements performed under changed condition. So, kapag may mga nagbago ng condition, parehas pa rin ba yung results na yun? Halimbawa, temperature sa ating laboratory or volume ng sample or mga iba pang factors. Reliability. So, the ability of the analytical method to maintain accuracy and precision over the extended period of time. Kung maganda yung reliable, kumbaga, kahit matagal mong gamitin yung machine, same pa rin yung accuracy and precision niya. Kung mataas yung load or yung mga samples, ganoon din yan. So, practicability, the degree to which method is easily repeated. Since automated naman na tayo ngayon, madalang na maging issue yung ating practicability. Usually kasi yun yung sa ating manual method pa lang. So, diagnostic sensitivity. So, parang siyang sensitivity pero in-incorporated lang natin siya sa disease. So, ganoon din yung diagnostic specificity. Delta check. So, the current test value is compared to a previous value or value to detect large changes. So, kapag may previous result ka, i-check mo yung result natin ngayon. Halimbawa, kinunan siya ng dugo kahapon, tapos kinunan ulit siya ng dugo ngayon. So, i-check mo if malaki yung nagbago compared do sa kahapon. So, if medyo abnormal, pwede mong doon ka magagawa ng decision if repeat extraction or i-rerun mo muna yung sample. So, depende sa ating delta checking. So, let's proceed to quality control. So, quality control is concerned with the analytical phase of quality assurance. So, nasa isang phase lang siya ng ating QA. So, nasa analytical phase lang. So, it is the process of ensuring that analytical results are correct by testing known samples that resembles patient samples. So, yung ating mga control samples or control solutions, alam natin yung kanyang result range. May resulta yan. Alam natin yung concentration niya para siyang standard. Pero, pang quality control natin siya. Yung ating quality control na yon, dapat pag nirun mo sa machine natin, pasok siya doon sa range na ibibigay ng ating mga manufacturers. So, halimbawa, 1 to 10. Yung dapat yung results niya pasok sa within 1 to 10. So, yun ay mabibase natin sa ating SD. Mamaya, pakita ko sa inyo yan. So, it involves the process of monitoring the characteristics of the analytical process and detects analytical errors during testing and ultimately prevents the reporting of inaccurate patient test results. Since alam natin yung kanyang value or yung kanyang results, yung value yung ating malalaman natin if okay yung running ng machine or nung procedure sa oras na yon. So, mag-run ko ng quality control mache-check mo if may error ba sa magiging procedure. If okay yung result ng quality control, ibig sabihin okay yung procedure. If hindi okay, then makakapag-troubleshoot ka, hanapin mo saan siya may problema. So, quality control running depends on the institution. Usually, it is run once a day. Usually, pagka mga night duty. Minsan naman, pag mataas ang load mo, pwedeng twice or thrice a day. Depende sa kung kailan kailangan siya. Kung ilang test na halimbawa, for every 100 samples, kailangan magra-run ka ng quality control. So, depende yan. So, there are two major types of quality control, the internal QC or intra-laboratory QC and the external QC or inter-laboratory QC. So, internal QC, ito yung analysis of control samples together with patient specimens. So, ito na nga yung ginagawa natin from a day-to-day performance of the laboratory, usually every night. So, it is important for the daily monitoring of accuracy and precision of the analytical methods. So, daily to. External or internal laboratory, inter-laboratory QC, so involves proficiency training programs that periodically provide samples of unknown concentration to participating clinical laboratories. It is important in maintaining long-term accuracy of the analytical methods. So, external QC, ito yung ating meron tayong reference laboratories. So, yung reference laboratories, magpapadala siya sa inyo ng sample na unknown yung concentration. Unknown para sa laboratory na magra-run. Pero alam yun ng ating reference laboratories. So, yung sample na yun, halimbawa, for glucose, alam yun nung nagpadala sa atin kung ilan yung concentration nun. So, iraran natin to for a period of usually 1 year. I-determine natin yung kanyang concentration, aalamin natin. So, yung ating ipapasang result, dapat tally do sa binigay nila or do sa concentration na alam nila. So, alam nila, itetest natin. Pag parehas siya, ibig sabihin, maganda yung ating results. Okay tayo sa external quality control. So, the objectives of quality control is to check the stability of the machines, to check the quality of reagents, to check technical and operator errors. So, number 1 is for the machine, kung okay ba yung ating machines, kung walang mechanical or software problems. To check the quality of reagents. Kasi lalagyan natin yung reagents sa machine. So, pwedeng ma-expire, masira yon, gawa ng mga external factors like humidity, temperature. So, kailangan ma-check natin yun if pwede pa siyang gamitin. Last is to check technical or operator's errors. Ito yung sa pag-run na. Kung magkakaproblema siya, depende sa nagamit. Kung sino yung magpa-process ng ating mga samples. So, control solutions or QC materials. So, they are solutions that are used to check the precision and accuracy of the analytical method. It should resemble the patient sample and be run with the patient. So, dapat kagaya siya or same siya ng matrix ng ating mga patient sample. So, the characteristics of ideal control solution, they should behave like real samples, available to last a minimum of 1 year. So, in-update kasi natin yung baseline tsaka yung kanyang mga Levey-Jennings. Kaya, mas maganda, matagal natin magagamit yung QC para hindi tayo paulit-ulit magraran nung para sa ating control charts. So, they should vary minimally in concentration and composition from vial to vial. So, syempre, small aliquots lang yan or konting samples lang yan per vial para hindi siya ma-expose sa temperature changes, humidity, para hindi agad masisira. So, dapat yung ating aliquots or yung iba't iba nating vials, mga bote, pare-pares dapat yung, or halos pare-pares dapat yung concentration nun. So, there should be no communicable diseases. Usually, mga bloodborne diseases ito like Hep C, Hep B, syphilis, yung ating mga bloodborne diseases na pwedeng makakahawa through sa ating samples. So, dapat walang ganun. Malinis dapat. Analytical errors. So, they are errors encountered in the collection, preparation, and the measurement of specimens, including transcription and releasing of results. So, yung ating mga error na pwedeng magawa. So, random error. So, they are errors that occur unpredictably or unpredictably. So, hindi mo alam, bigla na lang siya magkaka-error. Tapos titignan mo kung bakit. Pag rerun mo naman, okay na. So affects precision and is the basis of varying differences between repeated measurements. So yung tipong nag-run ka, nag-error, nire-run mo, okay na. So parang random lang siya. So random error, examples niya is sa variations ng technique. So ito yung mga usual kung bakit nagkakaroon ng problema. So pipetting error, mali yung pagkakapipet, kulang or sobra. Mislabeling of specimens, so niran mo siya para doon sa isang test, hindi naman pala siya para doon. Improper aliquoting. Environmental changes like temperature, humidity. So temperature and voltage fluctuation, ito yung sa ating machine. So mga random lang, parang biglaan lang, wala ka namang ginagawa doon sa machine, bigla siya nag-error. Systematic error, so errors that occur predictably once a pattern is recognized or recognition. So, pag nakita mo may pattern na siya, mamaya may kita niyo examples ng ating mga patterns. So, problem is constant and predictable from day to day. So, detected as either positive or negative bias. So, pwede siya maging trend. So, ang trend is a values increases or decreases for 6 consecutive days and it crosses the mean. Ang kanyang cause is the deterioration of reagents. So, nasisira na yung reagent. Ito yung ating Levey-Jennings chart. Ito yung mean. So, ang mean is yung parang average natin or nasa gitna. Plus 1S is standard deviation. Pwedeng 1SD or plus 1S lang. S or SD, maalin yun doon. So, pataas, ibig sabihin, pataas yung value compared sa mean. Pababa is pababa yung value compared sa ating mean. So, ang statistical deviation natin dito is 0.1. So, plus 1S meaning plus 0.1. Plus 0.2 plus 0.3 pag negative or pababa. Positive bias is pataas, negative bias is pababa. So, on trend is 6 consecutive. Bilangin natin. 1, 2, 3, 4, 5, 6. Or dito. 1, 2, 3, 4, 5, 6. So, may trend siya, pataas. So, crosses the mean. So, pwede natin simulan siya dito. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9 na siya, pataas. So, ayun, kung mabasa mo. Mula sa day 4 or running number 4 hanggang sa running number 12. Pero pwede na siya natin ma-establish sa kanyang 6th day. 1, 2, 3, 4, 5, 6. So, day 9, ma-establish na natin siya may trend. So, pag day 10, pwede natin ma-estimate ay tataas ulit yan. So, pag run niya natin, tumaas nga siya. Okay? Next, systematic error is shift. Values distribute themselves on one side or either side of the mean for 6 consecutive days. So, they does not cross the mean. So, hindi siya nalipat. Causes of the error is improper calibration of the instrument. Okay, so bilang natin. Mean. Pwede ito. So, nasa mean siya, hindi siya kasali pa. Bilang natin. 1, 2, 3, 4, 5, 6, 7. So, pwede natin siya ma-establish dito. 1, 2, 3, 4, 5, 6. Day 11. So, nasa one side na kasi siya. Hindi naman siya pataas since, ayan, nag-ano siya. Naipon siya dito sa ating plus 2S. So, taas na. So, pwede pa madagdagan yan pag ganun-ganun lang. Hindi kagaya ng ating trend na makikita mo pataas talaga yung value niya. Yung value nun ay, ayan, ito yung values niya. Pwede mo naman tingnan din yan sa ating values mismo, sa ating tables or charts. So, basta pagka-trend, unti-unti siyang pataas or pababa. Pag shift, maiipon lang siya sa isang side ng mean. So, nasa taas siya ng mean. Ito yung baba. So, examples ng ating systematic errors is pwedeng due to calibration problems, deterioration of reagents and control materials, improper preparation of standards and control, contaminated solutions, unstable and inadequate reagent blanks, failing instrumentation, and poorly written procedures. Allowable errors, ito yung the quantity of error that will not negatively affect clinical decisions. So, total errors must be less than allowable errors to be considered acceptable. So, may mga error tayo na pwedeng i-accept, meron naman na kailangan i-rerun at ayusin. So, statistics. So, mean. Mean is the measurement of a central tendency or yung ating average associated with symmetrical or normal distribution. So the formula is mean is equal to summation of the numbers over n. So may equals dito sa gitna. Mean equals summation of the numbers or x. So x yung ating mga variables or mga control results. N is the number of samples. So parang i-divide mo lang siya. Para makuha yung average. Median, midpoint or the 50th percentile, yung gitna. So the value of that divides observation into two groups, each containing equally numbers of observations. So gitna. Mode, the most frequently occurring value, used to describe data with two centers or bimodal. So yung pinakamadaming beses na nag-a-appear. So pwedeng madami yan since most frequently occurring lang naman siya. Range, the simplest expression of distribution. So this stands difference between the highest and the lowest score in the data. So ma-minus mo lang yung highest tsaka lowest. Standard deviation, ito yung measurement of dispersion of the values from the mean. So yung kagaya na sa table kanina may plus 1 SD, 2 SD, 3 SD, or 2S, 3S. So measurement of distance range and most frequently used measurement of variation. Ito na yung ginagamit natin sa mga controls natin. So yung formula, SD equals the summation of x minus mean. So ito yung ating yung x yung ating mga data mismo per number. Ito yung isa-isa nating result. So halimbawa 1. So minus the mean. So kukunin natin yung mean, i-minus natin dito. Tapos i-square natin. Then isa-summarize or i-add natin siya para makuha mo yung total, yung summation niya. Then n minus 1. So total numbers minus 1, then square root. So bibigyan ko kayo ng computation nito para madali nyo maintindihan. So plus 1 SD or SD, 1 SD is 68% of the population yung sakop. 2 SD, 95% na. Ito yung maximum allowable standard deviation. 3 SD, 99.97% of the population. So pag 1 SD, konti pa lang yung difference niya mula sa ating mean. The coefficient of variation is expressed as SD as the percentage of the mean value used to determine precision. So COV, so coefficient of variation equals SD over mean. So pag ganito, mean yan. Variance is a standard deviation squared. So SD squared lang. Measurement of variability. Difference between values of the average of the data. So t-test used to determine whether there is a statistically significant difference between the means of two data groups. F-test used to determine whether there is a statistically significant difference between the standard deviations. So t-test means F-test standard deviations. So pinakamalimit natin ginagamit dito is yung ating standard deviation. So next is quality control charts. So number 1 is Gaussian curve or bell-shaped curve. So occurs when the data set can be accurately described by the standard deviation and the mean. So obtained by plotting the values from multiple analysis of a sample. So population probability distribution, this is symmetric and about the mean, occurs when the data elements are centered around the mean and most elements close to the mean. So ito yung example niya, bell-shaped, pataas. So ito yung ating 1SD. Pasok yung ating 68.2% ng data. 95.4 SD percent is 2 SD and 99.7 is 3 SD. So CUSUM, cumulative sum graph, CUSUM pala. Calculates the difference between QC results and the target means. So common method is the V-mask. So madalang gumamit ng ganito. So depende kung ano yung inyong ginagamit na system. So this plot will give the earliest indication for systematic errors like trends. Ito example niya. So V-mask. Yoden twist plot. So interlab. Used to compare results obtained on high and low control serum from different laboratories. Ito itsura niya. Shewhart Levey-Jennings chart. Ito na yung usual na ginagamit natin. Most widely used quality control chart in clinical laboratories. It allows the laboratories to apply the multi-rules without the aid of the computer. Yun ang ating Westgard. So it is a graphic representation of the acceptable limits of variations in the result of analytical methods. Identifies random and systematic errors. So ito yung itsura niya. So Levey-Jennings. So again, ito yung mean. Plus 1 SD, ito. Minus 1 SD. Plus 2 SD, minus 2 SD. Then 3 SD na yung iba. Quality control charts Westgard Multirules. So, established a criteria whether an analytical process is out of control. So, kung out yung ating quality control. So, according to Westgard, the use of simpler upper and lower limits is not enough to identify analytical problems. So, the combination of the control values used in conjunction with the control chart has been called the multi-rule Shewhart plot. So, ito kasi lang yung ating plot lang. So, kapag wala ba kang ginamit na multi-rule Shewhart plot, ito lang yung data mo. Pwede malalaman mo lang kung mataas yung QC or mababa yung QC. Wala pa yung rules na naka-apply. So, ito yung ating rules. So, random error and the systematic error. So, kapag random error, even, add yan, 1, 1R. Kapag ka systematic, even, 2, 4, 10. So, yun ang tatandaan. 2, 4, 10. Ito, 1, 1R. So, 1S, 2S. Wala yan. 1, 2S. Yan. So, 1 control value exceeds 2 SD. So, warning rule, accept the run. Pwede pa yan. 1, 3S. 1 control value exceeds 3 SD. Hindi pwede. Rerun or troubleshoot. R4S. The difference between two control values are equal to or greater than 4 SD. Hanap tayo. Ito ay 1 SD. Kapag yung iyong data or sample ay halimbawa ito lang, so 1, 2S yan. Ito pala, 1, 2S. Yan, 1, 2S to. Itong dot na to, 1, 2S. So, isa lang. Kapag isa lang, pwede kang mag-accept. Pwede mo siyang itanggap ngayon. Bukas, hindi na pwede. Pero depende pa din sa institution ninyo. Minsan, kailangan pasok siya sa 2SD. Pero sa rules, pwede siya basta isa pa lang. Next, 1, 3S. So, ito yun. Kung bibilangin mean, 1, 2, 3. Nasa 3S siya. So, hindi pwede to. Rerun. Ito, pasok to. Within 1 SD. Mga pasok yan. Ito. Okay, next. R4S. R4S, 4 yung pagitan niya. Hanap tayo ng 4. So, wala ditong 4. So, example, halimbawa, ito. Nandito yung data mo sa 12. Tapos, yung kasunod mong value dapat kinabukasan, 4 yung pagitan. So, bilangan natin. 1, 2, 3, 4. So, ito, tsaka dito. Itong dot na to, tsaka dito. Yun ang R4S. Systematic error, 2, 2S. So, 2 consecutive values that are greater than 2 SD. Ayan, ito. 2, 2S. Yan. 2 consecutive that are greater than 2 SD. So, ano sabi? Rerun na yan. Hindi na pwede. Out yan ng QC. Di ba 1, 2S kanina? Pwede pa. Pag dalawa na, rerun na. Hindi pwedeng i-accept yung QC na yun. 4, 1S. Iba yun sa R4S. 4, 1S. 4 consecutive control values on one side of the mean. Hanap tayo nun. 4 consecutive on one side of the mean. Ito. 1, 2, 3, 4. So, pwede na siyang 4, 1S. Ito din. 1, 2, 3, 4. 4, 1S. 10x, 10 consecutive control values on one side of the mean. Hanap tayo nun. 1, 2, 3, 4, 5, 6, 7. Kung dadagdagan mo pa, 8, 9, 10. Dapat sunod-sunod siya sa isang side. So, tingnan natin. Ito, 1S, 1S, 1S. Mga 1S to, normal to. Ito, nag-cross siya ng mean. Bilangan natin. 1, 2, 3, 4, 5, 6. Nag-cross ng mean, pataas. So, ito ay trend. Ito, 1, 2, 3, 4, 5, 6. Hindi nag-cross ng mean, shift. 2, 2S, 1, 3S. 1, 2, 3, 4. Ito pwede pala itong 1, 2, 3, 4. kulang pa. So, pag nag-ipod to ng konti or nag-ipod ng konti pataas, pwede siya sanang R4S. Ito yun, R4S. 4 yung greater than or yung difference niya. So, yun lang. Hanap na lang tayo ng examples or bibigyan ko kayo ng examples para sa ating quality control and standard deviation computation. Thank you.